Welcome to DC Digital Learning Session. I am Dr. Shobhan Kumar D, working as Assistant Professor, Department of Mathematics, Maharani Science College for Women. Today we have to discuss Newton divided difference formula. In last class already we know that Lagrange's interpolation formula. We have to estimate the value of y when x are unequally spaced. Then we can go for either Lagrange's interpolation formula or Newton divided difference formula. Now we have to discuss Newton divided differences. The Lagrange formula has a drawback that if another interpolation value are inserted, then the interpolation coefficients are required to be recalculated. The labor of recomputing the interpolation coefficients is saved by using Newton's general interpolation formula, which employs what are called divided differences. The concept of divided differences. Let the function y is equal to f of x be given at point x0, x1, x2, and so on xn, which need not be equally spaced. Equally spaced. If equally spaced, no problem. Here x are not equally spaced. And f of x not f of x1, f of x2, and so on, f of xn denote the n plus 1 values of the function at the points x0, x1, x2, and so on, xn. Then the first divided differences of f of x for the arguments x0, x1 is defined as f of x0 minus f of x1 divided by x0 minus x1, or f of x1 minus f of x0 divided by x1 minus x0. Both are correct. And it is denoted by f of x0 comma x1, or delta. This is a divided difference operator, delta f of x, or by within big bracket x0 comma x1. Therefore, f of x0 comma x1 is equal to f of x0 minus f of x1 divided by x0 minus x1. Similarly, I can define f of x1 comma x2, f of x1 minus f of x2 divided by x1 minus x0, or f of x2 minus f of x1 divided by x2 minus x1. And f of x2 comma x3 is equal to f of x2 minus f of x3 divided by x2 minus x3. These are the first divided differences. The second divided differences for the arguments x0, x1, x2, and so on xn is defined as f of x0, comma x1, comma x2 is equal to f of x0, x1 minus f of x1, comma x2 divided by x0 minus x2. Similarly, the third differences for the arguments, third divided differences for the arguments x0, x1, and so on xn is defined as f of x0, comma x1, comma x2 is equal to f of x0, comma x1 minus f of x1 minus x2 divided by x0 minus x1. This is the second divided. Here, third divided difference is f of x0, x1, x2, x3. Here f of x0, comma x1, comma x2 minus f of x1, comma x2, comma x3 divided by x0 minus x3. Here already we know that f of x0, x1, x2 and f of x1, x2, x3. Now here divided by x0 minus x3 and so on. Now we know the table, construction of divided difference table. First column containing arguments, second column containing entries, first divided difference, second divided difference, and so on. Here f of x0, comma x1 is f of x1 minus x0 divided by x0 minus x1. F of x1, x2 is f of x1 minus x2 divided by x1 minus x2. F of x2, x3 is f of x2 minus x3 divided by x2 minus x3. And second one, f of x0, x1, x2 is f of x0, x1 minus f of x1, x2 divided by x0 minus x2 and so on. We note that the first divided differences are called the divided differences of first order. The second divided difference are called the divided differences of order 2 and so on. The divided differences are symmetrical in their arguments, that is, independent of the order of the arguments. The nth divided differences of a polynomial of nth degree are constant. Now we take some few examples. If f of x is equal to 1 by x, then find f of a comma b and f of a comma b comma c. This is the first divided difference. Here f of x is 1 by x. This implies f of a comma b. F of a comma b is f of a minus f of b divided by a minus b. Here from these functions, we define f of a. Just replacing x by a, we get f of a is 1 by a, and x by b, we get f of b is 1 by b. Therefore, 1 by b minus 1 by a minus 1 by b, whole divided by a minus b, and simplify, we get minus 1 by ab. And f of ABC. F of ABC is equal to f of AB minus f of BC divided by a minus c. F of AB. Here we know that f of AB is minus 1 by AB. Similarly, f of BC is minus 1 by BC divided by a minus c, and simplify, we get 1 upon ABC. Therefore, f of a comma b is equal to minus 1 by AB, and f of a comma b comma c is equal to 1 divided by ABC. And another example, prepare the divided difference table for the following table, or construct the divided difference table for the given data. Data is given, x are given and f of x are given. X is 1, 3, 4, 6 and 10. F of x is 0, 18, 58, 190 and 920. In first column, here this is a divided difference table. In first column, x0, x1, x2, x3, x4. That means 1, 3, 4, 6 and 10. And second column containing entries are nothing but f of x, 0, 18, 58, 190 and 920. Now first divided difference is 18 minus 0, or 0 minus 18 divided by 1 minus 3 is 9. Here 18 minus 58 divided by 3 minus 4 is 40. And 58 minus 190 divided by 4 minus 6 is 61. 190 minus 920 divided by 6 minus 20. 6 minus 10 is 182.5. Second divided difference. Second divided difference is 9 minus 40. 9 minus 40 divided by 1 minus 4 is 10.33. And here 40 minus 61. 40 minus 61 divided by 3 minus 6 is 7. And 61 minus 182.5 divided by 4 minus 10 is equal to 10.25. Third divided difference, here 10.33 minus 7 divided by 1 minus 6. 1 minus 6 is equal to 0.3660. And another one, 7 minus 10.25 divided by 3 minus 10 is equal to 0.4643. And fourth divided difference is 0.6660 minus 0.4643 divided by 1 minus 10 is equal to 0.1248. This is the divided difference table for the given data. And next one is find the divided differences of f of x equal to x cubed plus x plus 2 for the arguments 1, 3, 6, 11. Here x are given, y's are not given. Here given the y in the form of polynomial. First you have to find the f of x at x0 is equal to 1, x1 is equal to 3, x2 is equal to 6 and x3 is equal to 11. Therefore, here x, this is y. F of x at x equal to 1, we get 4. F of x at x equal to 3, we get 32. f of x at x equal to 6 is equal to 224. F of x at x equal to 11, we get 1,334. Now write on the construction. Now construct the divided difference table. Here first divided difference for table 4 minus 3 2 divided by 1 minus 3 is 14. And 3 2 minus 2 to 4 divided by 3 minus 6 is 64. 2 to 4 minus 1 double 3 4 divided by 6 minus 11 gives 2 2 2. Second divided difference is 14 minus 64 divided by 1 minus 6 is 10. And 64 minus 3/2 divided by 3 minus 11, 19.72. Third divided difference is 10 minus 19.75 divided by 1 minus 11 is 0.976. Now we have to discuss Newton's general divided difference formula. Newton's general divided difference formula or Newton's interpolation formula for unequal intervals. In earlier cases, we discussed Newton's interpolation formula for equal intervals. That is nothing but Newton's Gregory interpolation formula that is understood that to only equal intervals, x are equally spaced. Here we have to discuss Newton interpolation formula for x are unequally spaced. Okay, let y is equal to f of x takes the values f of x0, f of x1, f of x2, f of xn corresponding to the arguments of x0, x1, x2, and so on xn. By definition, first divided difference f of x comma x0 is f of x minus f of x0 divided by x minus x0. From this, f of x is equal to, here from this result, just rearranging f of x is equal to f of x0 plus x minus x0 into f of x comma x0. Call it as 1. Similarly, f of x comma x0 comma x1 is equal to f of x x0 minus f of x0 x1 divided by x minus x1. And rearrange from this result, we get f of x comma x0 is equal to f of x0 comma x1 plus x minus x1 into f of x comma x0 comma x1. Now, substituting in 1, this is f of x comma x0 in 1, we have f of x is equal to f of x0 plus x minus x0 into f of x0 comma x1 plus x minus x1 into f of x comma x0 comma x1. That is f of x is equal to f of x0 plus x minus x0 into f of x0 comma x1 plus x minus x0 into x minus x1 into f of x comma x0 comma x1. This is 2. Proceeding in this way, we get f of x is equal to f of x0 plus x minus x0, f of x0 x1 plus x minus x0 x minus x1, f of x0 x1 x2 plus x minus x0 x minus x1 x minus x2 into f of x0 x1 x2 x3 plus and so on. Last term is x minus x0 x minus x1 and so on x minus xn x minus xn minus 1. This is f of xn minus 1 n minus 1 n minus 1 into f of x0 f of x0 and so on xn. So on x. This is 3. If f of x is a polynomial of degree n, then f of x, x0, x1, x2, and so on xn is equal to 0. Hence 3 becomes f of x is equal to f of x0 plus x minus x0 into f of x0 x1 plus x minus x0 x minus x1 into f of x0 x1 x2 plus and so on x minus x0 x minus x1 and so on x minus xn minus 1 into f of x1 x2 and so on xn. This is called Newton's divided difference interpolation formula or Newton's interpolation formula for unequal intervals. Now we have to discuss some examples. Use Newton's divided differences formula. Find f of 6 from the following data. F of 6 from the following data. Here we won't bother about either x is nearer to beginning interval or nearer to end of the interval. Only one formula is a divided difference formula. Okay. Here the arguments are 5, 7, 11, 13, and 21. X are unequally spaced and corresponding values of f of x are 150, 392, 1452, 2366, and 9702. Now I have to find f of 6. First, construct divided difference table. Here, x in first column arguments 5, 7, 11, 13, 20. Second column entries 150, 392, and so on 9702. First divided difference. First divided difference already I told you either 150 minus 392 or 392 minus 150. If 392 minus 150, here in denominator 7 minus 5. Okay, both are interchanging. Here 392 minus 150 divided by 7 minus 5 is 122. And here 1452 minus 392 divided by 11 minus 7, 3265. And 2366 minus 1452 divided by 13 minus 11, 457. And 9702 minus 2366 divided by 21 minus 13 is 970. And second divided, this minus this divided by this minus this is 24. And this minus this divided by this minus this gives 32. And this minus this divided by this minus this gives 46. Third divided difference. 32 minus 24 divided by 13 minus 5 is 1. 46 by minus 32 divided by 21 minus 7 is 1. And fourth divided difference is here in the numerator 1 minus 1, 0, 0 divided by 21 minus 5 is also 0. Now we note that from the difference table, here upper values are always important. These are the leading divided differences. This is f of x naught x1. This is f of x naught x1 x2. This is f of x naught x1 x2 x3. This is f of x naught x1 x2 x3 and x4. Here x4 is 0. You note that. Now write down the divided difference formula. F of x equal to f of x naught plus x minus x naught into f of x naught comma x1 plus x minus x1 into f of x naught x1 x2 plus x minus x naught x minus x1 x minus x2 into f of x naught x1 x2 x3 plus here no need to write because here f of x naught x1 x2 x3 x4 is 0. Okay, therefore it becomes 0. Stop this state. Now here x is equal to 6. We have to estimate the value of f of x at x equal to 6. Here put x is equal to 6 and substitute all the values and simplify, we get 252. And another one, using Newton's divided difference formula, find f of 8 and f of 15 from the following data. Here x are given, y f of x are given. You can write down first, construct the table, and then using the formula Newton divided interpolation, once we take x is equal to 8 and again we take x is equal to 15, we get f of 8 and f of 15. And another one is determine f of x as a polynomial in x for the following data. Here we have to find the f of x in terms of x only. First, construct the divided difference table by using the given data. And here we can write down the formula. Can write x as it is, no change. Okay, here we don't put any value for x. Now we have to find polynomial. Here can write x as it is and remaining x0, x1, x2, x3, x4, we know the values. Substitute and simplify, we get 3x to the power 4 minus 5x cubed plus 6x square minus 14x plus 5. Similarly, we can do these problems. Okay, thank you.